Hey math kids, today we're going to talk about financial mathematics. We're in chapter 5, section E, and this will definitely be broken into multiple videos because there are, I think, 10 examples. Alright, so we're going to be using this. This is your final amount. This is your initial amount that you invest. This together is like your interest. And then this is how often it's compounded per period. So compounding. Okay. Now we're going to do example 12. So we have $5,000 and we invest it for 4 years at 7%. And is compounded annually. So you take the years and you multiply it by how many times each year it's compounded. So it's really just going to be 4 times 1, and that's going to get us our n value. So this is n. This is our I value, but we're going to write it as 0.07. And then this is our u naught value. So we plug that in to this above equation. So it's going to be u4, because our n would be 4. Our initial amount is 5,000. And then we do 1.07 because it's this number plus 1. Then we raise it to the n, which is 4. This wasn't equal, so that's multiplied. Whoops. Okay, so we come to our calculator. I guess I gotta open it. I don't know where it went. There we go. And we just type it in. So we say 5,000, parenthesis, 1.07, raise that to the 4, and we get 6,553.98. So that's the total amount that would be in the account. And that's what the first part asks for. And then the next part asks how much interest was earned. And so we want to just subtract 5,000 from that. You can go to your calculator to do that if you want. But that is the amount of money we actually earned in that 4-year period. Okay. Now we're going to move on to 13. And that's my best attempt at a pound symbol. If it helps you, just write a dollar symbol. Because the number will come out the same. Just know that pounds and dollars are different, but that for the math in this, it won't make that much of a difference. And then it's compounded quarterly. Okay, so I'm going to rewrite the formula. Okay. Now, this is our u naught. This so quarterly means 4 times per year. So our n is actually going to be 16, because 4 times 4. And then our interest is a little tricky too, because the quarterly affects that as well. And so it's going to be 0.03 divided by 4, which if we do that, it's 0.75%, which is going to, so that's percent, which is going to translate into 0.0075 when we plug it in. So this entire thing is going to be 1.0075. Okay, so we'll plug this in. U of 16 equals the initial amount, which is 5,000. 1.0075 raised to the 16. We go here. Since it's the same form as the last one, I'm going to do an entry. We already have 5,000. And then this is 0.0075. And that, raise it to the 16. Hit enter. And we got 5,634.96. Okay, and so the total, technically we should write this pound symbol, but I'm not very good at that. So 5,634 and 96.96. Okay, now we're moving on to example 14. Gonna need to get some room over here. Okay, so this one says, how much does Ivana need to invest now to get a maturing value of $10,000 in 4 years, given interest is 8%, and it's compounded twice annually? Give your answer to the nearest dollar. Okay. So we don't know our initial value, but we know our ending value. So once again, we have un, u naught, 1 plus I raised to the n. So this is the formula we're using. This is actually our un. This we need to multiply it by 2, so our n is actually 8. And then this we need to divide by 2. And so we're going to get 4%. And so this piece is going to become 1.04. Alright, so we plug that all in. We get 10,000 equals u naught, 1.04, and then we're going to raise that to the 8. Now, in our calculator, we're just going to call our u naught an x, but we're going to, since we haven't learned how to do this algebraically yet, we are going to just use a graphing calculator. And so once again, we type in 10,000, because that's the left side of the equation. Type in the right side, which is going to be x times 1.04. Close that, raise it to the 8. And then we want to change our window. So we want to make sure our y max can see that 10,000. So I'm going to say 11,000. And I'm guessing we'll need to, let's say 100. Well, let's see. Probably more than that. Because how much would we need to invest? I don't know. I'm just going to say 1,000 to be safe. And we'll see what happens. Oh, 1,000 wasn't enough. See how over here they don't cross? We need more space on the x-axis. We go back to the window. And I'm going to say 6,000. Just see what happens. Okay, we're definitely getting closer. Are we going to make it? Nope, didn't make it yet. So we need to make that bigger. Let's just go to 10,000. Graph that. Alright, so right here, we actually could have done this algebraically, I just realized. That's okay though. So we're going to go second calc, go down to intersect, first curve, second curve, then we're going to guess where they cross, right there, and it says 7306, let's see, 7306.9, so we'll say 7307. Okay, and that's the amount of money that she needs to invest so that in 4 years, at this percent, being compounded twice a year, she'll end up with $10,000. Okay? And we'll keep going. Okay, example 15. Georgia would like to purchase a painting that is currently worth $5,000. She makes monthly deposits into an investment account so that she can purchase the painting in 3 years. if inflation averages 2.5% per year, this is inflation, calculate the value of the painting indexed for inflation for 3 years. Okay, so essentially, let's write that formula one more time. Okay, so we're using this thing again. Alright, the initial value was right here, so 5,000 goes right there. Our percentage is going to be 1.025 because the value will increase just due to inflation, and we're looking at it for 3 years. So we just need to plug this in to our calculator, and then we're good. So we say 5,000. I'll move this over a little bit. 1.025 raised to the 3, and then we end up with 5384.45. So that's the final value of the painting after 3 years. So that's the amount she would need to save up for if she's going to buy it in 3 years. All right, let's keep going.